Hey everyone, in this video we're going to talk about rational exponents, and this is just fractional exponents. So when you hear the word rational, you can think about fractions. So for example, let's begin with square root 25, which we know is 5, and that's because 5 squared is 25. So if we square 5, we get 25 in return. Now, if we start with this version where we're going to take square root 25, square it, it's the same thing as 5 squared, and we get 25. Okay, all of this is going to lead into our rational exponents. So it appears that squaring a square root cancels it out, or undoes the square root. So we could rewrite square root 25 as 25 to some power. Okay? So what is this power? So square root 25 squared, well, what is that exponent, that missing power right here on 25? Well, think about the rules of exponents. What number needs to go right here where I have a question mark for the result to be 1? Well, if we have from our power rule a power here raised to another power, the rule is to multiply. And so the answer to that question mark would be a 1/2 power. So what that means is the square root can be rewritten with a 1/2 exponent. So square root 25 is the same as 25 to the 1/2 power. And then from our rules of exponents, 1/2 times 2 is just the 1 exponent, and so we get back to 25. So let's try it with this one. Cubed root of 25 is just 25 to the 1/3 power. And then 4th root of 25 is 25 to the 1/4 power. And so on. So 5th root 25 is 25 to the 1/5 power. So we are now able to change radicals into a different form. And this is using rational exponents. So exponents that are fractions. So in general, we can go from radical form if we know what the index is, and we get nth root of x is the same thing as x to the 1/n power. So that index goes into the denominator for the fraction or the rational exponent. So let's simplify. So simplify 81x to the 12th quantity to the 1/4 power. We now know that when we see a rational exponent, a fraction exponent, it actually represents a radical. So this is the same thing as the 4th root of 81x to the 12th. So you can rewrite anytime you have a rational exponent in terms of a radical. So the outcome now here must be positive, and that's because we are dealing with an even index, a 4th root. Anytime the root is an even root, square root, 4th root, 6th root, and so on, the outcome has to be positive. And so we have 3 because the 4th root of 81 is 3, and then x cubed because the 4th root of x to the 12 is x cubed. So think about it. The question was asking what number times itself 4 times gives you 81. That number was 3. What quantity of x times itself 4 times gives you x to the 12th? Well, that would be x cubed. Now, we do have to make sure that we guarantee this is positive because it was an even root. And so all you have to do to change this to make it positive is put absolute value bars around x. So now, in general, again, we have that x to the n raised to the 1/n power is the same thing as x to the n, but inside the nth root. So remember, when you see a fraction exponent or a rational exponent, that part can be rewritten as a radical. So this is the nth root. And then remember what we know about radicals. If we have the nth root of x to the n, this radical is going to undo this power on x. Now this is true if n is odd. If n is even, we just have to add our absolute value bars to make sure that this, whatever was possibly negative, is positive when we take this nth root of x to the n. Now we can extend the definition of x to the 1 over n power to include fractional exponents with other numerators, so not just a 1. So here's another example. This time we have 8 to the 2/3 power. So until now, if you've never seen rational exponents before, you would see this and you wouldn't really have any idea of what to do here. How do I simplify this? Well, now we know if you have a rational exponent, that fraction actually represents a radical. And so if we start to break this apart, 2/3 is the same as 1/3 times 2, and then we can rewrite that as a cubed root. Okay, so cubed root of 8, quantity squared. So the 1/3 power represented a cube root, and then we can simplify this so much easier now because we know the cubed root of 8 is 2. Okay, because what number times itself 3 times makes 8? That number is 2. And now we just square from the outside and we get that this is 4. So now we know 8 to the 2/3 power is really just 4. Okay, so there is a different way to approach it. You could switch the order that you write this. So 2/3, you can break it down as 2 times 1/3, and so you can put the 1/3 power on the outside of the quantity. This is just exactly opposite of what we did the first time. And now we have that that's 64 to the 1/3 power. And now the next step is to recognize that the 1/3 power represents our cube root. So then this question is, what number cubed, or what number times itself 3 times gives you 64? Well, that number's 4. So you can approach this either way and you will get the same answer. So if m and n represent positive integers, as long as n is not 0, the following is true. And this is going to come in handy when you work with rational exponents in the future or just radicals in general. So the further up in math that you go, you're going to have to refer back to this fact. It'll come up over and over again. So x to the m over n power, so the exponent is a fraction with m as the numerator and n as the denominator, can always be rewritten as a radical. Okay, so you can rewrite it either way here. You can put, well, what's going to stay the same, let's start there, is that the n, the denominator, is the index, so it's the nth root. Now the optional part is where you place m. The numerator, m, it's the exponent on x, but you can either put it inside the radical with x, or you can actually put it all the way outside with parentheses and put the radical inside. So either way works. It's just sometimes, depending on what you're working with, the values, one of these two ways of simplifying or rewriting might be easier to work with, but these are both true. So a to the n normally means to multiply a by itself n times. But it doesn't make sense to multiply a by itself a fraction number of times. And so that's what we're talking about, fraction exponents. So what exactly does the fraction exponent indicate? Well, let's take a look. 32 to the 0 we know is 1, and then 32 to the 1 is 32. So any power in between, so notice these numbers are all greater than 0, but less than 1. So any power in between 0 and 1 here, well, the answer has to be between 1 and 32. And so we just talked about it. 32 to the 1/5 power is exactly the same thing as the 5th root of 32. And that's 2. Okay? Because what number times itself 5 times gives you 32? That value is 2. This example, 32 to the 2/5 power, you rewrite it. The index is from the denominator, so it's 5th root, and the numerator is the new exponent, the power here. Okay, so 5th root of 32, quantity squared. So this version, it makes more sense to put the power or the numerator 2 outside the radical because we know the 5th root of 32. We know that that's 2. So it's just 2 squared, which is 4. So let's try this one. We're going to rewrite this with a radical. It's going to be 5th root of 32, quantity cubed, and then again we know 5th root of 32 is 2, so this is just 8. And let's see if you understand what this is going to be before I show you. So we're going to rewrite 32 to the 4/5. This is going to be 5th root of 32 to the 4th, so that's just going to be 2 to the 4th, which is 16. And so all these answers were definitely in between 1 and 32. Alright, now you can also rewrite the original answers, the first and the last, with rational exponents as well. 32 to the 0 over 5 power is still a 5th root, but to the 0 power, which just becomes 1. And then 32 to the 5 over 5 power, this undoes itself. 5th root of something to the 5th power, those two cancel out or undo each other, and so this is just 2 to the 5th, which is 32. Okay, let's try this one. We have parentheses around negative 64, so that whole quantity is raised to the 2/3 power, and so that's going to be a radical because it's a fraction exponent. So this is cubed root of negative 64 quantity squared. So remember, the denominator from the exponent is the index on your radical. The numerator is the power on the radical. Okay, so cubed root of negative 64 is a real number because there is a real number, negative 4, that multiplies 3 times to get you negative 64. So you simplify the cubed root first, and then you can square it, and we're going to get 16. So negative 64 to the 2/3 power is just 16. How about this one? Quantity 36 times x to the 6th, all raised to the 3/2 power. So we see this rational or fractional exponent. We know we are about to rewrite this with a radical. So square roots. I want you to notice something. The denominator of the exponent here was a 2. So that's a square root, and a lot of times people don't write the little 2 here in the index. So if you don't see a number in the index, you assume it's 2. It is an invisible 2. So this is a square root. And then the numerator 3 is the power on this radical. So from the inside, we know that square root of 36 is 6, and square root of x to the 6th, you're asking yourself, what squared gives you x to the 6th? And that's x to the 3rd. So x to the 3rd squared would have given you x to the 6th. So it's that quantity, still cubed from this outside 3rd power, and then you multiply this out, 6 times 6 3 times, and then x to the 3rd to the raised to the 3rd, your rule is to multiply. So that's x to the 9th. How about this one? Notice that the negative sign on the negative 625 is not in parentheses. So this exponent does not actually affect this negative sign at all. With our negative exponent, we are going to move the base, and I'm purposely making a mistake here. Let's see if you can catch it. So we have negative 625 to the 3/4 power. Okay, so what's incorrect is that I actually brought the minus sign with the 625. There was no parentheses holding it there, and so this exponent was not addressing the negative sign, so we're actually going to rewrite this in just a moment. So what the mistake might have been is if I keep going forward, I would think that this is the 4th root of negative 625 quantity cubed. But this is incorrect because of the fact that there was no parentheses around the negative and the 625. So then if we fix this, it was really just a -1, and so the 625 had the negative exponent, so that moved to the denominator, and the negative sign came off of the exponent. Then we can rewrite with a radical, and this represents the fourth root because the denominator is 4, and then that quantity to the third power. And so we can say, well, what number times itself 4 times is 625, and that number's 5. So 5 cubed on the bottom, and we have -1 over 125. All right, take a look. This time we are starting with a radical. So this is not a rational exponent. However, we might want to rewrite this with a rational exponent. So right now we have the 9th root of 27x to the 6th times y cubed. So we can rewrite that so that the 9th root is written as a 1/9 power. So 1 over 9 fraction exponent is the same thing as a 9th root of this quantity. Now why that's going to help us is because we can use our rules of exponents right here and simplify. So first of all, let's just break down 27 as 3 cubed. And then we know that if we have a product to a power, that power gets multiplied onto each of these other exponents. So then 3 times 1/9 is 3/9. 6 times 1/9 is 6/9, and then so on, 3 times 1/9 again. And then we can simplify. 3/9 is 1/3, 6/9 is 2/3, and then 3/9 is 1/3 again. Then we can go back into radical form. So these are all to the something over third power. So all of these denominators were 3. Therefore, that's a cubed root. Those all go inside of a cubed root. The 3x and y go into a cubed root because all these denominators in their exponents were 3. And then their powers, the numerators, go back on the factors. So 3 to the 1 is right here. X to the 2 is here. And then y to the 1 is here. Alright, one more here. X to the 4/3 power times a quantity, okay, with x to different powers. Now, rules of exponents. There is no rule for when you have the same base and you're adding. The rule that we went over is if you were multiplying the same base, you could therefore add the exponents. So just be careful about that. The rule is not to add them in this case because we are not multiplying. There's a plus sign in between. So what we actually are going to do is we're going to distribute the x to the 4/3 from the front into both of these terms. Now at this stage we can add the exponents, and here's the difference. Now we are multiplying x times x. Over here, x times x. So that is our power rule, our product rule. So we can add the exponents now. And so we have 4/3 plus 2/3 on our first x, and then over here we have 4/3 plus -1/3 from this these x's getting multiplied. And then if we simplify, that's x to the 6/3 in the first term, and then the second term we have x to the 3/3, and both of those numbers we know that is x squared plus x, or x to the invisible 1.